You are listening to The Vocal Technologist. Spoken tech for your ears.
You know, if you feel like the whole industry just went from zero to warp speed in like the last 3 months, you are definitely not alone. It's not just about the flashy demos anymore, is it?
Yeah.
We're watching these huge tectonic plates shift under our feet.
It's more than that. It's burn the boats level commitment.
Exactly. Financial commitments that are just reshaping Silicon Valley and fundamental infrastructure changes that redefine what software can even do. This is the stuff we love getting into on Vocal Technologists.
For sure. The sheer scale of what's happening right now is, well, it's hard to get your head around, even if you've been in this field for a while.
Right.
So our mission today is to try and explore two big ideas that are linked here. First, just the unbelievable scale of investment that's flowing in. And second, how that money is actually being used to tackle that final mile problem.
Moving from models that just predict things to what? True agents.
To true, trustworthy, autonomous agents that can act for us.
Okay, so we're going from the staggering dollar amounts in the headlines down to the new chips they run on, and then deep into the really critical technical bottleneck, managing context.
That's the key.
All right, let's start with this financial frenzy, because the numbers they're just getting beyond ridiculous. They feel surreal. I mean, last year, AI companies raised a collective $222 billion.
Which was a record.
A record. But what's happening now feels like we're in a totally new orbit.
It's an investment frenzy that, I mean, it really defies historical comparison. Look at Anthropic. They're planning to raise $10 billion.
$10 billion.
Which would put its valuation somewhere in the neighborhood of $350 billion.
Yeah.
And then you have Elon Musk's XAI, which just secured $20 billion into Series E.
From who? The big players.
Oh, yeah. NVIDIA, Fidelity. These aren't just big raises. They're capitalization events that totally redefine what a company with early or even no revenue can be worth.
It's a staggering number of zeros to think about in such a short time.
And OpenAI.
Yeah.
The scale there is just as immense. Last fall, they were valued at $500 billion, and they set aside $50 billion for an employee stock grant pool.
50 billion.
50. That's 10% of the entire company, just for equity.
That's an unbelievable commitment to keeping your talent.
And they're already in talks for another round, this time at a valuation around $750 billion.
So here's where it gets really interesting for me, though, because the talk among investors, it's not just about the raw amount of money or the valuation anymore. It's shifting to something much more specific.
Gross profit per token.
Exactly. Gross profit per token.
That metric is basically the new language of monetization. It shows how efficiently a company can turn the actual use of the AI, the influence, into real repeatable revenue.
And the correlation is, it's kind of wild.
It is. The analysis we saw showed a 0.71 correlation between a company's gross profit per token and its valuation.
And for anyone who doesn't do stats, 0.71 is huge.
It's a massive statistical link. It means if you can monetize a single token just a little bit better, your company's value just skyrockets, way more than if you just sell more tokens.
It's funny, right? We used to measure growth in users or engagement. Now it's the microscopic economics of one token.
It's a huge mental shift, prioritizing efficiency and pricing power over just raw scale.
So who are the leaders in this?
Well, Perplexity, which is an application layer company, they get the highest GP per token multiplier. It's a 222x.
Wow.
And that reflects their strategy, right? They're monetizing the direct application. They capture the full value of the user's search query and the answer they provide.
So they're sitting right on top of the user, extracting the most value from that final experience.
Precisely. And then on the other side, you have companies like DeepSeek and Together AI. They have the lowest multiples.
Why is that?
Because their model is focused on reselling inference. They're basically providing the raw horsepower for other people to build on.
So it's a difference between building an app on the models versus building the infrastructure for the models.
Exactly. And right now, the market is heavily rewarding the application layer's efficiency.
Okay, so all this money isn't just sitting in a vault somewhere. It's fueling this shift from models that just answer questions to agents that actually do things. And that's hitting our personal lives and our work lives, like, right now.
Yeah, we're seeing this big push for personal integration, especially in really high-stakes areas like wellness and health. OpenAI just launched ChatGPT Health.
Okay, what does that do?
It's designed to help you by securely integrating your personal medical information to give you a more personalized experience.
That sounds incredibly powerful, but wait. Integrating sensitive data, like medical records, That immediately raises huge cybersecurity red flags for me.
And that's a crucial point. It links directly to the risks we need to talk about. The decision to integrate that kind of regulated data is a massive leap in capability.
But it also exponentially increases the security you need. The trust factor is just, it's everything.
Absolutely.
And at the same time, Google is going after productivity. They're putting Gemini right into Gmail.
With the AI overviews.
Right. You can query your own inbox in natural language, like, tell me the 3 things I owe Sarah before Friday, or just summarizing those monster email threads. It's like an executive assistant for everyone.
And if you connect that to the enterprise space, the agent revolution is all about specialization and verification. We need agents that don't just act, but act reliably.
Which is where things like agentic rubrics come in.
Exactly. They allow for this test-free verification of code changes by using other expert agents to create these like checklist-style evaluations.
Wait, test-free? How do you stop the expert agents from just rubber stamping bad code or getting bias?
Well, that's the clever part of the rubric structure. It gives you an interpretable signal for reinforcement learning. So instead of just pass-fail, the agent gives a detailed checklist explaining why the code is good or not.
Ah, so the human operator can see the logic and the learning system gets specific feedback.
Precisely. It's essential for training reliable agents at scale.
And the performance we're seeing from these specialized agents is, I mean, it's genuinely shocking.
Look at WebGem. It's this environment with like 300,000 real-world web tasks.
Yeah.
A fine-tuned Gwen 3VL model is now outperforming even the big generalist models like GPT-4o.
On specific, unseen web navigation tasks, that's huge. Gwen is an open source model. To see a specialized version beat the biggest players in their own niche, that shows how fast this is all moving towards vertical expertise.
We're even seeing it in gaming. There's this thing called Nitrogen. It's a generalist gaming agent trained just on internet gameplay videos.
Just on videos, yep.
It can predict controller actions directly from the pixels on the screen and then adapt to games it's never even seen before.
So it's not just watching a YouTube video. It's translating blurry pixels into what? Press A, move stick right, jump now.
That's it. It's handling the full stack from perception to essentially physical control in real time.
So that's the transition. We're way past just predicting the next word.
Far past it. These systems are solving complex problems. They're showing real reasoning. But to make them reliable, especially in an enterprise setting with customer data or critical infrastructure, we have to solve the context challenge.
Right, the engine room, the nuts and bolts. If an agent is going to approve a financial transaction, it needs the full, messy history of why things happen, not just what the data says in this one moment.
Exactly. Context is fast becoming the next major data platform. And things like context graphs are essential to ground an agent's reasoning.
It's not just the data, it's the relationship knowledge, as you called it.
Right. It captures process info and these crucial decision traces. What decisions were made, what events changed things, why an account moved from one stage to another.
So the implication here is that our current systems of record, which just log the final result, they're not good enough for true automation.
That's it. Salesforce, for example, is a great system of record. But it's not a source of comprehensive context because it doesn't have those decision traces.
It tells you what the sales total was, but not the 5 meetings that changed the client's mind and why the deal shifted.
Precisely. Context graphs let agents automate that kind of distributed work because they capture the underlying intent and process.
Okay, that makes total sense for reliability. But practically, how does this work? How do you stop an LLM from getting overwhelmed by a massive context window or just forgetting things?
It's a huge question about managing the AI's working memory. And one really powerful solution is something called recursive language models, or RLMs.
Okay, break that down for me.
So instead of the main model having to read and summarize every single piece of context and probably losing detail, RLMs delegate memory management to submodels.
So an analogy might be the main LLM is the CEO.
Perfect analogy.
Yeah.
The CEO needs to focus on the big decisions. The RLM is like an executive assistant who takes notes, organizes old project summaries, and only presents the distilled, relevant info right when the CEO needs it.
So you're teaching the AI how to manage its own memory.
You are. It makes its long-term memory stateful and flexible.
That's really clever. And what about for coding agents? There were some token-efficient strategies there too, right?
Yes, that brings us to dynamic context discovery. Tools like Cursor use this. Instead of loading a whole static repository every time, it only pulls the relevant bits of data during inference.
Like just grabbing the blueprint for the one part of the house you're working on?
Exactly. It might only load a summary of the past chat or specific tools when they're needed. It's incredibly token efficient and much faster.
And finally, what about personalization? Making an agent remember my preferences.
That's handled by context personalization. It uses structured memory objects to create a stateful, long-term memory. So the agent can recall your preferences, store facts about you, and evolve its behavior based on past interactions. It breaks out of that single-session memory limit.
Okay, so we've got the money, the agent capabilities, the technical fixes for context. Let's pull the lens back a bit. Let's talk strategy, competition, and the risks of moving this fast.
Well, on the competition front, the global stage is still incredibly tense.
Wow.
U.S. models have held the frontier since 2023, but Chinese open-weight models, like the Quinn we mentioned, are applying serious pressure.
How far behind are they?
On average, the top Chinese models have lagged U.S. capabilities by about 7 months, but that gap is always closing.
But not everyone is just playing the more compute game. Anthropic has that totally different strategy, the do more with less idea.
Which is fascinating. They are directly challenging this industry belief that scale is destiny. They're betting that with a fraction of the compute and capital, they can stay at the frontier through algorithmic efficiency and smarter deployment.
It's a bet on brains over brawn, basically.
In a way, yeah. Intellectual leverage over raw hardware.
Speaking of hardware, that pressure is driving the hardware race like crazy. NVIDIA has the Vera Rubin chips coming in the second half of this year.
And they're promising a tenfold cost reduction over the current Blackwell generation, which is huge.
And AMD is right there with their MI440X chip, which is designed more for smaller, decentralized corporate data centers.
So high-end AI is becoming faster, cheaper, and more accessible to everyone, not just the hyperscalers.
But this speed, this breakneck speed, creates massive risk. A big concern that was highlighted is that companies are integrating these powerful AI tools without proper threat modeling and security analysis,
Creating genuinely dangerous cybersecurity risks.
We're automating critical processes before we even understand the new ways they can be attacked.
It's a huge vulnerability. And it really underscores why you still need human intelligence at the top of the stack. AI is not a replacement for deep human knowledge.
It's a tool that needs expert guidance.
Right. That's why you see companies like Mercer hiring poets and economists to create the evaluation frameworks for these models.
Yeah.
You need top talent to teach an AI what good actually looks like.
It's like the AI coding agents can automate tons of tasks, but you still need that foundational technical knowledge and human oversight to really maximize their potential and, catch the subtle errors.
So if you put it all together, you see this incredible financial and tech momentum driving agent capabilities forward. But the bottleneck for reliable, widespread use comes down to two things: securing the system and managing messy, real-world context.
It's an amazing tension, isn't it? Capability versus control. We have agents that can perform complex reasoning, they can control gaming environments, but when you scale that up to dozens of agents automating your workday, how are we supposed to manage all of that?
Right. We've established the agents are capable, but the user interface to control them is still incredibly primitive. It's often just a chat window.
Which brings up a final, maybe provocative thought for everyone to chew on.
Yeah.
If we need to manage these complex multi-agent systems, assigning tasks, seeing their status, getting alerts, who is best suited to design that control interface?
The thinking here is that the answer is actually game designers.
Game designers.
Think about it. They have spent decades figuring out how to let humans direct incredibly complex multi-agent systems in real time. Think of the interfaces in a real-time strategy game. The status bars, the attention management.
Oh, that's a great point. Making something incredibly intricate feel intuitive and managing human attention when a million things are happening at once.
That skill set might be the most essential one for designing the next generation of AI user experiences. It's where psychology and information architecture meet.
Because the best model in the world is useless if it's impossible to control.
Or, understand, the user interface, not just the model, will define the limits of human-AI collaboration.
Something to think about. What kind of control group would you assign your own work agents to? Thanks for joining us. We'll catch you next time.
Spoken Tech, for your ears.